710, electron configuration part 2. Now, I just wrote part 2, and I didn't put the work to do yet because this might take several videos. This is a lot of information, and I might just do it in parts just because it's a lot of stuff, and I'm kind of doing this I'm actually doing, sometimes I do these videos in between the classes too. But basically, here's the bottom line. The worksheets that are in this 7.9 and 7.10, what you'll do is you'll look back. First, you'll do all of 7.9. You're going to do all the electron configurations of everything, okay? There's like 8 elements there. I'm going to tell you how to do the other 2 in a moment. Then, when you take that, when you take your elements, like say you did the electron configuration, you know, the whole thing for, I think one of them is, I don't have it in front of me. Oh, well. Oh, no, I don't have them in front of me. Carbon is one of them, I think. Maybe manganese is in there or something like that. Well, anyway, what you'll do, you'll look at it and you're going to analyze the worksheet. So you'll take your worksheet, like and say, look at letter A, and then in this part, you're going to look at worksheet and tell me about element A and go through it. And then here, A, B, C, D, E, F, G, and, you know, all of these A, B, C, D, E, F, G, H, A, B, C, you know, everything in this part, these first sections all refer to your old worksheets. Then this is going to be some different stuff that doesn't. So it'll probably take a couple of times work. We won't go over all of this in this lesson now. We'll do a lot of it, but okay. So here we go. Let me go back to where I was yesterday and let me kind of review. I've been leaving this on the board because before I erase it, I wanted to kind of get it back to you. Oh, here it is. I was trying to find the eraser. Okay. So some things you need to know about Hakotel. First of all, you need to know how to draw this. To draw this 1S, 2S, 2P, 3S, 3P, 4S, 3D, 4P. This tells you the order that the rooms in Hakotel fill up in. Or another way to look at it, if I come over here, you know, I could take this pattern and just draw my whole little, like a seating chart, or what do you call it? Or actually, you know when, back when you could go to movies and stuff, and you went to a movie, and you come in, and now they pretty much all have the stadium seating. You're going, okay, where do you want to sit? And they show you, they turn it around, they show you this chart. You want to sit in, you know, 7E, 7R, whatever it is. You pick 17F. You pick where it is, you know, on the seats. Well, think of it this way. This tells you where the little rooms are. Well, instead of seats, they're rooms, but every room can hold 2. So 1S, 2S, 2P, then comes 3S. 1S first, then comes 2S. 2P is next. And remember, there must be 3 rooms. Anytime you come to a P, there must be 3. Oh, I got it over here. Anytime you come to a P, there has to be 3 rooms in the P level. All right, so 2P. Okay, all right, then comes 3S, just 1 room. Then comes 3P, because there's 3 rooms again. Then comes 4S, 1 room. Then comes 3D. Anytime you come to D, there's 5 of them. Okay? Then, if you continued on, there'd be 4P. There'd be 3 of them. Okay? 4P, 4P, 4P. Then would come 5S. Then would come 4D, 5 of those. Then 5P, 3 of those. And 6S. So you kind of need to memorize that little bit. You're really not likely to ever have to draw anything more than that, even in my class or on an AP exam. But you know, if I were to ask you, even in general, if I were to ask you something about the higher electrons, I could take some element and just say, well, just tell me from 4S, how does it look from 4S up to 5P? And you could just draw 4S, 3D, 4P. You know, you could do those 5 or 6 and go from that part of the element up. But you know what? Right now, that might sound like a hard thing to do. So don't even think about that right now, okay? Because I'm going to show you some stuff. After you've gone through a few more video lesson sections, it's going to become a lot easier to you. This whole thing. In fact, this, you're not even going to really need it that much. Maybe I'm going to get into that today a little bit. I might just do that and talk about the chart. But you'll see. It'll come into play. You're not going to need it as much. But the reason I tell you that is because this is something that you will never forget. Like 2 years or 3 years from now, you're in college taking chemistry, and you're like, oh yeah, electron configuration. Oh, wait a minute, what goes first? Is it what is it? Well, if you know 1S, 2S, 2P, 3S, 3P, 3D, the 4th floor, 4s, 4p, 4d, 4f. Then just go spdf all the way to 7. Then do that. This will tell you the order they fill up in. So you will probably not ever forget this. And then the other thing to remember is when an s level is full, it has 2 electrons. So in other words, s goes all the way up to 2. It's full. The p level, when it's full, it has 1, 2, 3, 4, 5, 6. It goes all the way up to p6. So it maxes out at p6. Any of these, 3p6, 2p6, 5p6, whatever. D's will max out at 10, and that because there's 5 rooms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So D10, then once you get to D10, now you know it's time to move to the next level. Okay? And then F's max out, there's 7 of them at 14, and you're almost never going to see any F's anywhere really at all. Oh, I can make a mess out of that. F14. So S2, P6, D10, F14. Okay. Now that I've shown you that, I'm not going to erase it all yet. I want to continue with ions first of all. Okay, so I told you that when you're making the electron configuration for an ion, you know, if it's negative, you just gain electrons. Like, for example, if I, let's see, let me pick one. I already showed you oxygen. I showed you that one already. Like I said, oxygen, atomic number is 8. So if oxygen has 8 electrons, Z equals 8 for oxygen. So 8 electrons. So just go 1, 2, 3, 4, 5, 6, 7, 8. Okay, which means 1s2, 2s2, 2p, 1, 2, 3, 4, 2p4. Now see, you can also do this without this chart here. You don't have to have that chart if you're in your mind, if you get kind of better at it. Because you know, the first room is 1s. Because remember, 2 plus 2, what a mess I wrote that. 1s2, 2s2, 2p4. 4 plus 2 plus 2 is 8. 4, 5, 6, 7, 8. Oxygen is number 8 on the chart. Okay, forget the charges. That was something else I had there. So, I can just, another way to do oxygen is say, well, okay, here's oxygen. 1s. So first I've got 8 electrons. 1s, 2 of them can go there. It maxes out at 2. Then comes 2s. It will max out at 2. 1, 2, 3, 4. I have 4 more electrons. The next room is 2p. Can I fit 4 in that? Yes, they can all fit there. You can fit up to 6 there. So 1s2, 2s2, 2p4. So you don't really have to have this. In fact, you'll see in a minute, well, a little bit later on, I'm going to show you some more shortcut. But here's another thing. If I want to do oxide, O makes a charge of -2 when it combines, when it reacts. O -2. So, -2 just means it gained 2 electrons. It still has atomic number 8, but it has 10 electrons. Remember, oxygen, -2, because it has a, well, it's always going to be +8 nucleus for oxygen, but outside is -10. The electrons are, there's 10 electrons. So, 1, 2, 3, 4, and that means I've got 1s2, 2s2, 2p. That's going to be a 6, 7, 8, 9, 10. It gains 2. So oxide will gain 2 more electrons. They go right here. This chalk is getting small, and I've got to go get my other chalk. I think it's outside. Can't run to my car now. But okay. All right, so here's what we'll do. Now, what happens when you have a positive ion? All right, let me try and get this stuff out of there for a minute. Well, actually, I can do, well, you know what, now that I did that, I think I'm going to keep it there, but oh well. Let's do this one. What element is 1s2, 2s2, 2p6, 3s1? What would that be? 3s1. 1s2, 2s2, 2p6, 3s1. Well, one way to do that, we're going to show you an easier way even later. 6, 7, 8, 9, 10, 11 electrons. 6, 7, 8, 9, 10, 11 electrons. That will be sodium. So you look on your chart, you say, oh yeah, sodium has 11 electrons. As I said, I'll show you a better way. Okay, so that is your sodium metal, is 1s2, 2s2, 2p6, 3s1. Now, sodium makes a common charge of +1, Na+1. That means you lose an electron. And so here's the rule. Listen carefully. Remember, in the Hog Hotel, this is the order you fill up in. And you pretty much start at the low levels and you go up to the higher. Now, you skip around a little bit, I told you, because of the negative repulsion that builds up. it starts to kind of, a few go up here into the 4s, then they come back down to 3D and so forth. And that happens a lot in here. In fact, look at, I think it's F, 4F. Yeah, look at what happens. You fill up, after you fill up 4D, then you fill up 5P, then you fill up 6S. After 6S, then you go back to 4P. 4F, I'm sorry. 6S, 4F. So it's like, remember the hog, smelly. Oh, it smells so bad. So, I'm going to be repelled up to the level 6. But then you come back down and you finish filling up 4 and 5 again. 4F and 5D, then back to 6. So there's a lot of weird stuff like that. But anyway, it pretty much goes in order, maybe jumping around a little bit as you fill up. Well, here's the deal, though. When you lose an electron, ionizing, sodium loses, you always lose it from the highest floor of the hotel. Always. Okay, always from the highest floor. So what that means is, okay, it won't be a big deal for sodium. Sodium, the highest electron is in the hotel, the highest hotel room is 3s1. So it's going to lose that one right there. That's the one electron it will lose. So sodium ion is 1s2, 2s2, 2p6. Now, I guess I can throw in one other word here. You're going to see it later on, but I might as well tell you. Sodium had 11 electrons. Sodium ion only has 10. It loses one. When it loses an electron, look, neon also has 10 electrons. When sodium loses an electron, it doesn't change into neon because it still has 11 protons. Now, you might remember the identity of an element is based on the nucleus, the protons. If you have 11 protons, you'll always be sodium, no matter what. You can change whatever things about you, positive, negative, whatever, electrons, but you're positive, you're still. Okay, so, but it has the same electron configuration as neon. And I'm going to bring this up. This is in another section, but I'm jumping ahead. Neon has 10 electrons, 1s2, 2s2, 2p6, 6, 7, 8, 9, 10. So we call those isoelectronic. And you're going to see it later, but I just thought I would tell you now. Isoelectronic means they have the same electron configuration. So two things can have the same electron configuration, but they're different elements. But there can be something similar to them about reactivity. In fact, it's something that I would throw in there now. I guess I'll tell you already. You know, noble gases do not react, like neon. Well, sodium, in this form, it's very reactive. But once it loses that electron, when it has we call this a full shell, meaning everything, when you lose that electron, everything from the bottom floor all the way up is completely full. It becomes more stable and like unreactive. So sodium plus 1 is no longer reactive. Okay. Well, anyway, a lot of elements, when they become isoelectronic with a noble gas, they become non-reactive, and we'll show you that. Well, I'll say stable because they could possibly. Now, the harder one would be, I think I told you, titanium. Let's do titanium plus 2. And yesterday I did titanium, or yesterday lesson, because it was yesterday for me, but 22 electrons in titanium. Let me see, 22 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So for titanium, the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, oh boy, 3d2. Wow, I'm going to run into my little chart here. Soon this chart's going to go away. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. This is the electron configuration of titanium. Now, if I lose 2 electrons, let's just say I want to turn this into titanium plus 2.